Alright guys, if you're watching this video, you probably just need a little bit more guidance as to how to deal with expanding fractions and simplifying with fractions as well. So I'll just go straight to it. I've got all the questions here. If you want to try them first, please do, so you can pause the video. If not, you can just listen to me, that's fine as well. Okay, so normally when you expand a bracket, you'd obviously know that you'd multiply this with this and then multiply this with that, and then you're done. Now, when you've got fractions, it is the same thing, it's just that it's more technically slightly more awkward. So 2 over 3 times 4a. Now I'm going to draw that here, or write that here, sorry. So 2 over 3 times 4a. That's what we're looking at really, at that one there. Now the best way to deal with it is to firstly ignore the a really and go 2 over 3 times 4 over 1a. Because 4 is the same as 4 over 1. 2 times 4 is 8. 3 times 1 is 3a. So therefore, that, when you expand 2 over 3 times 4a, that is 8 over 3a. Now, a lot of you might think, well, that is the same as saying 2 and 2/3. It is, but in vectors, I think it's nicer that we leave it as improper fractions, okay? And then we'd do 2 over 3 times 2b. So same thing, 2 over 3 times 2b. So it'd be 2 over 3 times 2 over 1b. 2 times 2 is 4. 3 times 1 is 3b. So it'll be plus 4 over 3b. Okay, just like that. Alright, you can try that one by yourself if you want to, or I can just go through it now. So I expand the bracket. So 1/3 times negative 2a. 1/3 times negative 2a is the same as saying 1/3 times negative 2 over 1a. 1 times negative 2 is, well, actually let's leave the negative here. So 1 times 2 is 2. 3 times 1 is 3, making that minus there. So it would be negative 2 over 3a. Okay, so it'd be negative 2 over 3a. And then here, 1/3 times 3b. So 1/3 times 3b. 1/3 times 3 over 1b. 1 times 3 is 3. 3 times 1 is 3. So 3 over 3b, which is the same. 3 over 3 is a whole. So therefore that answer actually is just 1b. So b. So it'd be plus b. And that makes sense because 1/3 times 3 does get you to a whole. So it's 1. Okay? So therefore that's how you deal these two. Now with this, we're in a situation here where, let's say you have expanded, now you need to simplify. So you've got 2a minus 4 over 3a plus b. Now the plus b we can't do a lot with, because we can't collect the like terms of that, because that's the only b. So we know it's going to be plus b in our answer. The 2a minus 4 over 3a we can. Now please remember when you do this, some of you may be able to do it in your head, and that's fine to a degree, but you will get mistakes as the numbers start getting a bit more complicated. So just, I reckon, start with the practice of, if that is over 3, you want to make this one over 3 as well. So think, what is 2 whole if it's something over 3? So that would be 6 over 3a, because 6 over 3 is 2, minus 4 over 3a. Now the reason why that's helpful, and then we've got the plus b there obviously. So the reason why that's helpful, 6 over 3 minus 4 over 3, 6 minus 4 is 2. So it'd be 2 over 3a, and then we're left with the plus b. And therefore that would be our simplified answer. And lastly here, we've got 3a plus half b minus 4 over 3a. Now again, we've got two like terms of a here. The b, that's by itself, so we're just going to put plus half b. Right, 3a minus 4 over 3a. I'm going to write this down here. 3a minus 4 over 3a. Right, as you know, we can only really do this if we have the same denominator. So that's over 3, so that one must be over 3 as well. So we think what over 3 equals 3. So 9 over 3. A minus 4 over 3a. 9 over 3 minus 4 over 3 is going to be 5 over 3a, and then we bring down the plus half b. And therefore, they are examples of how you use fractions in order to expand and in order to simplify. Okay?